Alright, tonight we're going to work on trying to understand where some of these triangle formulas come from. Over the first few sections of chapter 12, we're going to look at a couple of different triangle formulas that you might not be familiar with. And rather than have me just tell you, hey, these work, use them, I'd much rather have you understand where they come from. When you were a freshman or a sophomore, you spoke as a freshman or sophomore, you thought as a freshman or sophomore, but now that you're a junior or senior, we put away those sophomoric things and we'll try to get our brains a little bit fuller right now with some good information here. So let's start with our original triangle formula. Most of you have learned since you were little that the area of a triangle can be found by doing 1/2 times the length of the base times the height, always remembering that the height needs to be a perpendicular segment to that base. Now remember that formula comes from the fact that a triangle is just half of a parallelogram, and the parallelogram formula is base times height. So now we're going to use this idea to derive our second triangle formula, and that is area equals 1/2 times A times B times the sine of angle C. And so let's use that triangle that we just were working with, and let's adjust some of those labels a little now. Alright, so remember A and B, those are lengths of sides, and I can make those whatever sides I want. I'm gonna really keep my B the same, but now that's not really necessarily the base, it's just the length of a side. And I've got the other sides labeled A and C, and of course remember angle C is always across from side C. Now what I really want you to think about now then is how can I rewrite the height in terms of these other letters? And so remember that height has to be perpendicular, so I should be able to use a trig function here. And if I go ahead and I write this as the sine of angle C equals the opposite, or H, over the hypotenuse, or A. And now if I rewrite this now or solve it for the height, I'm going to get for an answer the height equals A times the sine of angle C. Now if you look back at our formula now, it shouldn't be too awfully hard to figure out where we get that from. Obviously the half and the B are still there, but now instead of the H, we've got that A times the sine of C. So really they're exactly the same formula. It's just that we've rewritten the H to be in terms of the lengths of the sides, which is really a lot more practical. Very rarely will we know the height of a scalene or an oblique triangle, but we certainly will know the lengths of those sides most often. Now the other area formula, the one that we refer to as Heron's formula, this one's a little bit harder to derive. It's going to take us a little more time to get through this. If I was you, I would stop and really try to process what we're doing here in some of these steps. Now remember that formula is the square root of s times s minus a times s minus b times s minus c, where s, remember, we sometimes referred to as the mid-perimeter. It's just the three sides added together divided by 2, remember. A lot of people make a mistake there, what they're dividing by. Remember, it's dividing by 2. And this formula is in your blue sheets. You can always refer back to that if you forget it. Now what I want to do right now is, again, I want to see how do we get this. How do you get this formula that looks so different than anything that we've ever seen before with triangle area? Right, so what we're going to do right now is we're going to actually start with the law of cosines. So where that first formula kind of is related to law of sines a little bit, this one is going to be definitely related to the law of cosines. And so if we write that, remember c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. What I really want to do is I really want to rewrite that so that we're solving for the cosine of c. Let's get cosine of c by itself on one side. And so I'm going to subtract a squared and b squared, and then I'm going to divide by negative 2ab. And then I'm going to divide the top and the bottom by a negative 1 so that everything is as positive as it can be. And I'm not going to show you any example problems tonight. I just want you to see where these formulas come from. we'll do plenty of examples in class, and quite frankly, these problems aren't very difficult if you have the necessary parts. Alright, so there we have the cosine of c equals a squared plus b squared minus c squared all over 2ab. Now we're going to use some trig ratios, or I'm sorry, some trig identities that we learned last chapter. Remember that sine squared plus cosine squared equals 1. So I could actually write sine as the square root of 1 minus cosine squared. Think about that for a second if you need to understand how I got that. Go through your trig identities and solve it right now to get sine by itself. And so now I can rewrite the sine of c as the square root of 4a squared b squared minus, in parentheses, a squared plus b squared minus c squared squared all over 2ab. If you're having a hard time understanding that, go through that and work that out. Alright, square our answer from above. And then take 1 minus that and look for a common denominator there. And I think you'll be able to see where this actually comes from. But seriously, if you don't believe me or if you really want to see that work for yourself, push pause right now and see how you get from cosine c equals that business to sine c equals this. It's pretty important that you have a good understanding, a good working knowledge of all of this. Alright. Now that we have this, we're going to go and use that area formula that we just talked about a few minutes ago. The 1/2 AB times sine of C. Really, Heron's formula is just a different rewriting or a different way to utilize the area formula we had before. So remember, area equals 1/2 AB times the sine of C. Remember that angle C has to be the included angle between those two sides. And now if I rewrite that, plugging in what I just let sine of C equal, it's going to look something like this. 1/2 AB times under the radical and all that stuff that I just had written down, 4a squared b squared minus a squared plus b squared minus c squared squared all over 2ab. You can see some things cancel out, and I can pull that 2 in the denominator out to write it as a fourth, and so now I don't have a fraction anymore. It's just going to be 1/4 times all of that information under the radical. Now I'm going to take a few steps here to do a whole lot of rewriting and algebraic manipulation. Remember, algebraic manipulation is just rewriting things to serve our purpose, remember. And now if you notice there, that's a difference of squares. I can take 4a squared b squared and call that 2ab times 2ab. And the second part obviously is a square. And I'm just going to rewrite that now. I'm going to rewrite it, break it apart, unfoil it, if you will. And so I have 2ab minus that whole quantity times 2ab plus that whole quantity. And again, I would never expect that you would do all these steps yourself, like just discovering this, but I do want you to see how we get from that original formula at the top of the screen right now to the one that we end up calling Heron's formula. Now if you notice, I'm underlining some things in green. Those things I'm underlining in green, if you regroup those, you should recognize right now that that would actually end up being a minus b squared, that's the one over on the left, and a plus b quantity squared, that's the one on the right. So I'm going to rewrite this again, grouping them differently and writing them in a way that kind of serves my own purpose right now to get to a different look. And so I've rewritten that left side as c squared minus a minus b squared, and I've rewritten that right side as a plus b squared plus c squared. Excuse me, minus c squared. And again, you might notice that that is the difference of squares again. That's a difference of squares. So again, I'm going to expand those out. And I'm also going to bring the 1/4 underneath now and make it part of the radical. If I make it part of the radical, that's really going to be 1/16. If you think about that, the square root of 1/16, what number times itself equals a 16th? That's really a 4th. Alright, so I'm going to put all that under the radical. And remember, that's the difference of squares, so now I'm going to expand that. Have it c minus that times c plus that. A plus b minus c times a plus b plus c. And under each of those terms, I'm going to break my 16 up so that it really is 2 times 2 times 2 times 2. Alright, and you're going to see that written now. Alright, so remember, at any point, pause, go back, try to figure out how exactly I got there. If you think I made a mistake, let me know. I may have. There's a lot of stuff going on here. But like I just mentioned, I'm going to break up each of those 4 factors now, and I'm going to write them, each of them over 2. Now if you multiplied all those 2 together, you would get 16. Alright, so that's where the 2's all come from. At the top, I'm just kind of rewriting them with the negative signs running through. So I'm getting rid of all those parentheses. And what I want you to notice right now is I want you to notice how these look a lot like the mid perimeter. That a plus b plus c all over 2, that is S. Now the tricky part here is, if you use a little bit of knowledge here and you look at it and you manipulate things a little bit, you should be able to see that that one right there is going to become S minus A. It's a good thing for you to try to figure out right now. If you look at that and you don't see it right away, try to figure out how come that really equals S minus A, and this one really equals S minus B, and this really equals S minus C. I'm going to leave that for you to figure out. And if you try real hard, maybe you put a good 15 minutes into trying to figure that out, come and ask me then. I'll be more than happy to show you how that works. Okay? But now it should be pretty easy to see that if I take all those pieces in blue there and I put them under the radical, that is Heron's formula. And so that's the square root of S times S minus A times S minus B times S minus C. Remember, that's S, where S is the mid perimeter, or the A plus B plus C divided by 2, and the A, B, and C are the lengths of our sides.